Hello everyone, we are starting a 2 video modules. In this module, we are going to focus on seeing an example of using visualization and data integration to find patterns in the electricity consumption data. We worked on this data set and actually we pre-processed it on one of the modules previous to this one. So in this specific video, we're going to look at a couple of ways that we could be using visualizations to see patterns specific for this data set. So let's get to it. So as always, we are going to be importing our modules and reading the data. One of the things that you want to pay attention here is that I am not going to talk over the parts that we talked about, in one of the previous modules, talk about the data pre-processing, but I'm going to click through them just in case that you want to follow along and find what we've done before getting to the points that we're going to be heavily discussing in this video. So these are the steps that we took to make sure that the data is pre-processed, it doesn't have missing values or outliers. So here now I want to start the pre-processing that is needed for the visualization that I want to create. The first pre-processing that is needed for this visualization is to reformat the data from a long format to a wide format. If you look at your data right now, let's say the first 48, every consumption value is listed as a row based on different time of the day. So every day of the data is basically 48 rows, and it is in comparison with having every day only one row with 48 columns. So this format is a long format, and we want to switch this to a wide format. And we saw for us to be able to switch from a long format to a wide format, we use the function that comes with pandas, pivot, and vice versa. To switch from a wide format to a long format, we use melt. So here we are using pivot. To use pivot, you have to specify your data frame, and then what is the value, exactly where the value is, value that, the numerical value. What do you want to be your indexes, as in your, the indexes that are shown about each of the data objects. And then what do you want to call your new columns. So once you run this, now you have this new data frame that is wider, and it has the date as your indexes and also all of these time. If you pay attention to these columns, you will see that they are not ordered in the normal order we are used to seeing. So for us to change that, I am finding the order that is basically customary, that's starting from the midnight all the way to the next midnight. And I'm getting that from the first 48 data. So this is the order, just this column. This is the order I want the column in the wide format to be. So I get that order exactly by this code, and I say I want to reindex the wide data frame. And once you specify axis 1, it's going to work on the columns instead of the rows. So once I run this, now I have my columns reformatted, and this is the data that I want for the next challenge. So in the next challenge, I want to create one line plot that shows all of the data per day. So I basically want to see each of these numbers in one line for each day. And that's why we reformatted data, because now it's much easier to do this code. We don't have to do a lot of Boolean masking inside the loop. We just have to go through each loop and just plot it. So the way we do this is very simple. Like I said, we go through each loop and basically we plot the row for all of the columns that they have values, and then I give the column order and like rotate them so I can see them better. So this is the whole data of a year. I can see them every year, every day. One line is here, so it's very useful. Now I'm able to look at my whole data in one visual. Like it's a year worth of data, and I'm looking at it in one visual. I can see there are specific patterns in the data. There is like a dip, and there is like the it increases, and then there is a peak, and of course we know this is like the the evening peak, and this is like the morning peak. It sort of like goes down and then comes up. So this is sort of like a summary of all of the data, and we were able to do this because we knew how to sort of like give this data a new structure based on the understanding that we have from the environment that this data is collected from. So let's see if we can do even better. See if we can like sort of tease out the data. Another thing that we know that is really important in people's society as far as trying to see if that is an influential factor in the data consumption or like in the electricity consumption is the weekday. So we want to be able to now have a separate visual for each weekday and see if we can sort of like see there is like a similarity between each weekday data consumption. So we're gonna have 7 different visuals, each for each weekday, and for all of those, for example, the first one's gonna be all of the Sunday weekdays in one visual, and then Monday, Tuesday, and so on and so forth. So to do this best, we actually need to do a different data pre-processing, because in the data pre-processing that we have here, we only have time or date. We don't know what weekday it is, but in our log format, we did have that weekday in the data. So we do have that weekday in the data. So what if when we do the pivot this time, we also add the weekday to the date? We know, I mean, this is, every day is going to be the same weekday. It's not going to change anything because they have like one-to-one relationship. But how it's going to benefit us now in our new wide data frame, we also have a weekday. And we can simply use that in our code here to separate basically the visual. So I'm going to create 7 visuals, and based on each weekday, I'm going to use Boolean mask and separate only those weekdays and then draw the visualization. So that's why we sort of like pre-process the data. That was a mouthful. Pre-process. I'm not sure if that's the best way to describe it, but let's go with it. So this is now for only Sundays. Then we have Saturday, and we can sort of start seeing that there is actually some sort of pattern, at least as far as where these peaks starts and where they end. I mean, we did see that generally all of these patterns are similar, regardless of the day, weekday. But now we can see for each weekday, these are more sort of like neater, or in a way that they follow the same pattern. So that's sort of like one thing we were able to sort of confirm, that based on each weekday, the electricity consumption profile might be different, or the similar weekdays are going to have similar electricity consumption profile. The next things we want to sort of like try to explain is what changes electricity consumption from it being sort of low here and then another being high here. And one of the things that might come to mind is this is coming from electricity consumption from a human society. One of the things that we are using a lot for as far as electricity is the ventilation. And so if the temperature is low or high, we use ventilation to adjust the temperature of our houses. So let's see if the which month of the year these data are at has an influence on if they are going to be higher or lower. Let's actually make it a little bit easier. Let's go with seasons. So let's pick 4 colors: blue for winter, green for spring, red for summer, and gray for autumn. So now we have to also use the seasons color, these colors for seasons. So what I've done here, I've created a 12-member list, and I tell myself that this is first month, second month, third month, and I know the first 3 months are winter, and then we have spring, and then we have summer, and then we have autumn or fall. So this is the way I'm coding this. But before I get here, I have to have a way to know which month each data row is. And to do that, I have applied a lambda function to the YDF, and I am getting the whatever it is from the beginning till I find the first slash, and I get that as my month. So if we look at the data here, whatever starts from the beginning and the first slash is basically each month. So I'm sort of like extracting that. So actually, let's take a look at it before we get into the next steps. I'm extracting that. Now I have, for each of these rows in the Y data frame, I have a number that pertain to the month that data row has. So now that I have it, now in my loop, when I am creating the plots, I figure out what month each of these rows are, and then based on that rows, I figure out what color each one of those each one of those line plots should be. And now I am able to, once I run this, now I'm able to look at the visuals, but also see that each of these lines, what month they are at or what season they are at. So once we do this, we can see actually there is a sort of a separation between blues are tending to be higher and the reds are tending to be lower. So we were able to see now that actually the season has an influence on the amount of electricity on each day has been used. So let's see if we can take another step to see if we can actually connect this pattern into another metric that is a little bit more detailed than the season. So let's see if we can actually find a way to bring temperature data to see if we can draw a visual that based on the temperature we will see different shades of color here, and it's going to be able to tell us if temperature is actually a factor in how much electricity in one day is going to be used. To do this, we're going to have to have temperature data. I mean, the data that we have, it does not have temperature data. This is our data. It does not have temperature data. This does not have temperature data. So for us to be able to have temperature data, we have to do some data integration. And the next video is going to focus on data integration.